Hello everybody. Today we're going to start with circuit solving again, and I want you to basically see what you were expected to do on your test. So you will be given circuits and you have to solve that circuit. And how do we solve a circuit? The best way for you is to draw a table like this, where you will see all R1, R2, R3, which means for every resistor, you're going to have to solve its current and voltage and the unknown R or resistance. So I'm just going to copy and write here whatever I have so we can see. So in R1, the only thing I have is 3 amps. So I have the current. In R2, the only thing I have is 9 volts. So I have the voltage. Should I erase that? In R3, the only thing I have is resistance. And in R total, the only thing I have is 54 volts. So as you can see, you have all these components, but they're useless for me because I can't solve any circuit, any component, unless I have 2 of them, because Ohm's law, right, it's resistance equal to voltage divided by current. So for me to be able to solve, I need to have 2 of these. And here I have 1, 1, 1, 1, so it's useless. So I go back to my circuit and I look to see what other information I can have that will help me solving this circuit. And if you go, you can see this is a series circuit, therefore current is the same everywhere. So if I have 3 amps for this resistor, therefore I will have 3 here, 3 here, 3 here. So all of them will have the same current, because in a series circuit, the number of electrons passing through every point, they don't change, right? Therefore, I will have here 3 amps, 3, and 3. So now it's easy. All I have to do is solve the unknown. For the parts that I have 2. So here my V is 9, my I is 3. So V divided by 3, 9 divided by 3. So I will have 3 ohms. Just in case you forget, R is equal to V divided by I. So here's my 3 ohms. I've solved that. And I come here. Here I need to solve for V. So V is equal to I times R. So 7 times 3 over here is 21. So V times I. So if this one is complete, I come to R total. I have my V and I have my I again. So I will have to do V divided by I. So R total will be 54 divided by 3, that's 18. So far, I'm getting all the marks. I'm doing a pretty good job. Now, I'm left here. Like, I don't know what to do here because I only have 1 known. So if you go back in here, you can see R total is 18. And we know in a series circuit, R total is equal to R1 plus R2 plus R3. So if this is 18, and my R1, I don't know, I gotta find. My R2 is 9. My R3, sorry, not 9, that's a voltage. My R1, my R2 is 3. My R3 is 7. So something plus 3 plus 7 is equal 18. That means 18 minus 10 So your R1 is equal to 8 ohms. So here's my R1, 8, and then you can use the Ohm's law. Again, V is equal to I times R, so 3 times 8 is 24. And you can always do a check at the end, because this is a series circuit. That means voltage total is equal to V1 plus V2 plus V3. And if you've done everything correctly, this should come up to 54. So your V1 is 24, your V2 is 9, and V3 is 21. So you can see 21 plus 9, 30, 30 plus 24, 54 volts. So that will be a check to make sure that you've done everything correctly. So that's our first circuit. Okay, so now in this picture, you can see a parallel circuit. So you can see current is coming, and then it's branching off into two parts. And as you know, current means number of electrons. Just suppose you guys have to go to different places. So if I have 200 people here, 100 can go here, 100 can go here, 50 can go here, 150 can go here, but the same people can't go to both directions. That's why in a parallel circuit, your current will divide into different. So you will never have equal current, just you did like as you did for the series circuit. You can't have that. But what you can have in a parallel circuit is that voltage is the same. So I'm just going to copy here again, like that one, all the ones that are available to me. So I start with R1. I have voltage 9, and I have current 2. R2, I have absolutely nothing. The only thing is given here that R1 is equal to R2. So therefore, that's 9 as well. Oh, sorry, that's not the resistance. I have to find it first before I could put it in. And yeah, looks like that's all we have in here. But again, R is equal to V divided by I. So here, I can find my R1. V divided by I, that means my R1 will be 4.5 ohms. 9 divided by 2, right? V divided by I. So since R2 is equal to R1, I will also have 4.5 in here. But that's not helping me anyways, because again, I have two components here that I don't know. So you go back to your circuit and you look and you see it's a parallel circuit. Therefore, voltages will be equal. If I have voltage here and here, therefore I have exactly 9 volts. So I'm just going to go here and then say if this one is 9, this will be 9, and this will be 9. So here now my problem is solved. So if this is 9, again, if I'm trying to find current, current means voltage divided by R. So here V divided by R will give me 2. So 9 divided by 4.5, it gives me 2. So therefore this one is solved, this one is solved. And I'm going to come here. In a parallel circuit, your I total is equal to I1 plus I2. Remember, in a parallel circuit, the current, total current is equal to the current of other one. So if I have I1 and I2, each one 2, so that's 2 plus 2. So my I total is equal to 4 amps. Therefore, I have my 4 in here. So now, R total is going to be this divided by this. So 9 divided by 4, it will give me 2.2 ohms. So that's how you can see your entire table is filled and the circuit is solved. So we're just going to do a little bit more complex circuit, and I will not expect this on the test, but it is good to know for those of you who want to, go to electrical engineering. I don't know what programs you're going to go into, but it's always just good to know how to solve complex circuits and simplify circuits, because as you can see in this circuit here, I have a combination of series and parallel. So you can see here my circuit is series and it branches off here. So I have one little tiny parallel section here and then one little tiny parallel section here. And these two sections are in series with this one. So if I call this V2 and V3, if I simplify it, it will look like this. So this is my 1, this is 2 and 3, and this one here is 4 and 5. So when you're simplifying it, you're changing a parallel circuit to a series circuit. And that's the only way for you to solve. So let's just start putting into the table what we have so we can start looking at it and start solving it. It's like a game and a puzzle. So I'm just going to start with 1. The only thing I have for 1 is 36 volts right now. Then I come to 2. My I2 is 2. My R2 I don't have. And I come here, my I3 is 4. And my V3 is 20. And then I come here, my R4 I don't have, my I4 I don't have, V4 I don't have, but V5 I have the amps, 5 amps. V5 I don't have anything, and I come to total is, sometimes they put V0 or V0, but this is same as V total. That one I have 72. So let's look and see what we can figure out. So let's start. I'm just going to use a different color. If this was my current coming, so you can see this I is going, and I have no clue what I1 is. But I can see current is coming here, and this current is coming here, and they kind of join together to create this one. So if this is made of this and this, therefore has to be equal to this. So 4 amps is coming here, 2 amps is coming here. Therefore, I1 will be 2 plus 4. And if you add 2 plus 4 is 6. So my I1 is 6 amps. Here, immediately I have the ability to solve for R1, because R is equal to V divided by I. So now my R1, V divided by I, will be equal to 36 divided by 6. That's going to be 6 ohms. So 1 solved and done. I'm going to come to R2, and you can see in R2, V2 is missing, so I can't do anything, but go to R3. I have I3 for V1 20, so therefore again V divided by I, well, I'm going to have 20 divided by 4, it's equal to 5. So now this one is solved. So now one thing is clear, is that this part here you can see this and this are parallel. Therefore, if my V3 is 20, my V2 has to be 20. They both are holding hands. You can see this branch and this branch, they're holding hands. Therefore, if V3 is 20, V2 has to be 20. Same voltage for parallel circuits. Different currents, but same voltage. So if V2 is 20, therefore V divided by R, 20 divided by 2, my R2 is 10 ohms. Problem solved. So I'm going to come here to V4 and V5, right? Remember, if this one is 2 and this one is 4, it looks like before it branched off, here, the current is exactly the same as here, right? So it had to be 6 before it became 2 and 4. Therefore, the current that goes through these two branches, it comes out as 6. So I can assume I had 6 here, right? Because 6 comes, branches off into 2, and then 6 comes here again, and then branches off into 2. So same current is coming. So if it's 6, I can see here 5 went here, and then what would be this one? If 5 is here, what will be I4? It will be 1. Because 5 plus 1 equals to 6. So if over here I have 6, then I will. And same goes for V total. If over here is 6, and over here is 6, and over here is 6, it looks like over here I has not been branching off. So V total will also have 6. But V4 will be 1 because, you know, basically 5 plus 1 is equal to 6. Right? So I can now calculate my R total. So 72 divided by 6. So here 72 divided by 6, that's going to be 12 ohms. So that's your total resistance. That one is solved, right? So I'm going to go and see if I can solve R4 and R5, and then I'm done. So R4, now I have the current for it, but I don't have the voltage, and I don't have the current, the resistance. But coming back to this picture, that's how it gets tricky when we have complex. Here, voltage is 336. Here, equal voltages, 20. There's no other drop, it's only 20. For parallel circuits, the voltage is exactly the same. I come to 4 and 5, I don't have it. But I have the total voltage as 72. That's why it's so important that I simplify, because sometimes I need to have a simplified version, because even though I have two branches, V4 and V5, the voltage across these two is the same. The voltage drop will be one number. So now, this is a series circuit, so 36 plus 20 is 56. So technically 72 minus 56 will be the voltage for 4 and 5. That's 16. So this will be 16 volts, which means V4 will be 16, V5 will be 16. They both will have the same number because these two branches are parallel. So here I have 16, here I have 16, and now easy to solve. So V divided by, this will be 16 ohms. 16 divided by 5, will be 3.2 ohms. So you can see now my circuit is solved. So I will post some practice ones for you, and it will be nice if you can just play and practice and get prepared for your unit test, because pretty much that's what I'm going to do. This is the most important thing for this unit, and then I'll leave some assignments for you to, if you wish to do, for the rest of this unit.